All right, everyone, this is our last video for vectors. And these are really the same problems we've been doing, except we're adding a word problem to it. So don't panic. All right, vector A has a length of 3 centimeters and an angle of 40 degrees from the positive x-axis. Vector B has a length of 8 centimeters and an angle of 70 degrees. Vector C has a length of 2 centimeters and an angle of 120 degrees. Rounding to 2 decimal places, find the magnitude and the direction in degrees of the resultant vector when the 3 vectors are added together. So first thing I do is I draw a quick picture. So what we have here is force 1, force 2, and force 3. So I'm going to have my force 1. We can look back up here, or I guess it's vector A, so I guess I can call it force A if you want, but I'm not. Watch me be daredevil. This is 40 degrees and 3 centimeters. So if you're confused where I got that, just look back at this right here. So that's my force 1. My force 2 is going to be, where's that? 8 centimeters and 70 degrees. I guess I could have made that a little steeper, but c'est la vie. And then the last one's going to be 120 degrees and a length of 2. So that's going to be 120 degrees is obviously less than 180. So it's going to end up being something like this, 120 degrees, and we are left at 2 centimeters. And this is different than Newton's for sure, but it's the same exact principle. All right, so here I'm going to say that we're at 3 centimeters at 40 degrees. Here we're at 8 centimeters at 70 degrees, and here I'm at 2 centimeters at 120 degrees. So let's find F1, let's see, F sub 1 of x is going to be 3 cosine 40. F sub 1, F sub 1 of y equals 3 sine 40. Okay, just put these here. This is going to be F sub 2 of x, or you could put the x first and the 2. Doesn't really matter to me. This is going to be 8 cosine 70, which equals something. F sub 2y is going to be equal to 8 sine 70. And then here I've got my F sub 2 of x. Sorry, it's 3, right? Third force is going to be 2 cosine 120. And then F sub 3 of y is going to be equal to 2 sine 120. And so I should have cosine for all the tops, which I do. And then I should have sine for all the bottom ones here, which I do. And you can go ahead and pause this video or fast forward, but I'm going to put the answers for each of those. 2.3, 2.74, negative 1. 1.93, 7.52, 1.73. Okay, so now what we need to do is we need to add those all up, and my f sub x is going to be adding up this 2.3, this 2.74, and this negative 1, and I end up with a value of 4.04. My f sub y, of course, is going to be adding up my y values down here. I do that, and I'm left with 11.18. Immediately, I'm pretty happy because where is my resulting force vector located? It is located in the first quadrant. And how do I know that? Well, if I were to graph 4 as my x component, that would roughly be 4.04, and then up 11.18. You can notice that our angle is going to be in that first quadrant. So we'll deal with that in a second, but first let's go and find the magnitude. So remember, our magnitude is going to be the square root of our f of x squared plus our f sub y squared. And in this case, we're going to be given 4.04 squared plus 11.18 squared. And that gives me 11.89 newtons. So that's one of my steps, but now I need to go back and find my theta, which is tan inverse of my f sub y over f sub x. And so my f sub y here is 11.18, so that's going to be 11.18. My f sub x is going to be 4.04. So doing that math, I get 70.13 degrees. And notice how I already checked that it's in the first quadrant because this was right for up 11. So I know that that angle right there is 70.13 degrees. If it wasn't, we would just have to calculate what it was. There we go, final answer. All right, this next one is gonna be one where we do get a negative and we're gonna have to figure out what that angle is. So you can go ahead and pause the video and read through the problem, but I'm just gonna summarize it for you. Basically, we have a dog walker with 3 leashes attached to one connective hub. So you basically have 3 leashes leaving your hand. They're all pulling in different direction. So dog 1 here is, actually let's go even faster than that. Let's say we've got 10 newtons at 300, or no, it's just 38 degrees. So that's dog 1, that's force 1. Force 2, the dog has 12 newtons at 290 degrees, and that'll be force 2. And our force 3 is, let's see, dog 3 is 5 newtons, 110 degrees. So that's going to be 5 newtons at 110 degrees, force 3. So you basically have to go with the problem and find the newtons in the degree for each dog, which is each force. So same thing here. If you want to try this on your own, go ahead and pause the video. But we basically have to find f sub 1 of x, f sub 1 of y. Okay, let's do this. So this is going to give me 10 cosine 380, and then this one's going to give me 10 sine of 380. This one is 12 cosine 290, and then this one is 12 sine 290. This one is 5 cosine 110, and then this one is 5 sine 110. And then doing that math, I get 7.88, I get 6.16, 4.10, then I get negative 11.28, negative 1.71, 4.7. Okay, now I have to find my f sub x, which is obviously adding up all my x values. So I'm adding up this one, and this one. And I get 10.27. Now for my f sub y, I'm going to add up this one, and this one. And I do get a negative. In fact, I get negative 0.42. Sorry about that. That's a negative 0.42. All right, so let's find the magnitude first, then come back to the angle, just because I'm feeling it. So our magnitude is going to be the square root of 10.27 squared, which comes from my f sub x right here, plus negative 0.42 squared. So that's going to give me 10.28 newtons. Now let's go ahead and just draw a quick picture of where this is located so it can help me find the angle. So I'm left with going right 10.27, then down negative 0.42. So my angle is going to be in the 4th quadrant. So again, I recommend just using the positive values, but it's up to you. You don't have to. Tan inverse of f of y over f of x, so this is 0.42, divided by 10.27. And I get an angle of 2.34 degrees, which makes sense, right? Because we were really not that far below the x-axis given this number right here. Well, that's that angle that should be located in this triangle. So we have to do 360 minus that angle, and that's going to give us our 357.66. Now, if it was in this quadrant, the 3rd quadrant, you could do something like 180 plus the angle you got there. You just have to, it depends on the situation. If it's in the 2nd quadrant, you would have to do 180 minus that angle that you got for your thing. So we've done these before. It's a very similar situation. So this is our angle right here. So our final answer is going to be 10.28 newtons, at 357.66 degrees. And if you're looking for more practice on these or more videos, you can go to the review packet where I do several more of these. Thanks.